students. I welcome you all for this online platform. So today we are going to learn about a course by the name Factory Simulation Laboratory with the code MN22611. So basically here we are going to learn about a powerful tool by name Visual Components, which is a software where we can do multi-simulations. So before we get into the factory simulation software, we need to understand the nuances of factory simulation. So what is factory simulation? What will be the outcomes here and what will be the learning objectives? So before we get into all these things, let us know the definition. So factory simulation is a process of creating a virtual model for any manufacturing system. The purpose is to analyze, optimize, and improve its performance prior to its execution. It is not the mechanism, not after you set up a factory, then you do these activities. No, this is going to be a virtual platform where we can do all sorts of design prior to its execution. Basically, all the models what we do here is a computer based models, so none of the things are going to be physical. Therefore we are free to use all our innovative ideas in going ahead with the design. The main purpose is to replicate the abstract of the real world system. So we have got factory operations. The factory operations are going to be mimicked here, and therefore we are going to allow the engineers and decision makers to test the different scenarios without disrupting the actual production. So therefore, it is going to act as an interesting way to go ahead with the factory layout configuration. Henceforth, factory simulation is a powerful tool where we can design layouts, where we can develop or optimize the processes. So why should we do this particular factory simulation work? What is the need? What is the necessity? The answer for all these questions are, in a traditional manufacturing setup, there are certain challenges for them. Say, for example, maybe challenges with respect to repetitive tasks or with respect to material handling, types of material handling, etc. But how do we overcome? So that's one of the interesting and question what we are going to give an answer. Then we need to have digital models, because models are the one which is going to provide act as an abstract of real world data. So therefore we need to have a digital model. Henceforth the process can be optimized or the process can be improved immediately. Then the third interesting factor is, today in the age of digital era, where predicting the analytics or the predictive analytics or the factory performance has to be significantly improved with the available data. So henceforth factory simulation acts as an interesting tool to do all these activities. Key aspects. What all are the key aspects are there? The key aspects of factory simulation, the foundation level, it is going to be the digital representation. We have got a system, we have got a process, we have got a product, whatever may be the thing. We have got a flow line. We need to represent everything in a digital platform. So initially, all the things has to be digitally represented. Once the digital representation is ready, then it becomes easy for us to further process. Obviously, once the process is done, we need to analyze the process. The reason behind this, we can identify the bottleneck, we can identify the flaw, everything. And the final thing is decision support. What sort of decision are we going to come out with? So components of factory simulation. When you want to simulate, what all are the components necessary? Basically, there are two approaches are there. Approach number one is top-down approach. Top-down approach is, we as such, we have got, let us take a huge factory, and from the factory surface, we can break down them into processes, and for each processes what all are the cells necessary, and for each cell what all are the machines necessary. Likewise we can, that is, the top entity will be the factory, and we narrow down to the components. And the second thing is a bottom up approach, where initially we have a process. From one particular process we built a cell, then cells put together, then it becomes a layout, then from the layout we can go for a department, then to a department we can go for a factory. So the English saying goes like this: when you want to reach the highest, start from the lowest. So let us go for the bottom up approach. So the first component here, what is necessary is the digital model of a factory. The factory in the sense the works part. What work are you going to do? And we need to develop a digital model for the factory. And the second interesting part is the material flow, because any raw material is going to enter on one side of a factory. Obviously, either it is going to be processed into a semi product or it is going to be a finished product. Some cases even it can be of assembly. based on the nature of the process, it is going to differ. Now the material is going to flow across the factory in different shapes, geometries, size, even some cases the methodology of handling also is going to change. So therefore we need to have a cautious study or an adequate knowledge, especially with respect to material flow and how the material is going to be transferred from one area to other, because that has to be thought of when we consider the fact of material flow. Then machines and equipments. We need to know the processes involved, and to do that particular process, what all are the relevant machineries necessary, what all are the equipments necessary and accessories, all the things has to be thought of prior to the design activity. And this is another interesting fact that human operators and robots, all the cases, robots may not be essentially necessary, and all the cases, human cannot be employed, especially in a faster as well as repetitive case. So we need to have a complete understanding what sort of operation are you going to do and what sort of accessory, that is a resource, maybe a human resource or a robotic resource, has to be considered. And the scheduling process and the logistics has to be thought of. The sequence of operation number one, two, or some cases there can be some operation three in between one and two. So those things has to be thought of. Therefore, we can ensure a smooth scheduling activity. And finally, logistics. Even logistics, of course, it's going to be on the major end, but still the software is capable or the factory simulation is adequate enough to accommodate the logistics philosophy in this regard. Types of factory simulation. There are different types of simulations are there based on the nature of the factory, nature of the process. Maybe they produce a product or they do the process. Based on that, we can go ahead with. However, the broad stratification is like this. The first is DES, discrete event simulation. Discrete event simulation is, it is going to focus on the events and the queues. Any processing industry, it is going to fall in this particular regard. Then agent-based simulation or ABS, individual entity interactions. We might be having different cells and how the interaction among the cells are going to occur. And finally, SD, system dynamics, high level flow and feedback loops. This is one of the flexible manufacturing concepts where the production rate will be high and often we have got an automated system to all these things. So again, based on the nature of the industries, the simulation can be, the type of simulation can be preferred. It need not necessarily be any one of this. Even some cases, their chances of hybrid is also there because of the latest advancements. Softwares. See, whenever we learn anything, we need to know the software, what we are using as well, what all are the competitive products available. Though the philosophy of working might be same, but still they are not same. They have their own unique distinctiveness. So therefore, we should have a thought process on the available softwares. No particular order. The first software is Visual Components, Siemens Technomatics, AnyLogic, Fluxysim, Arena. So these all are the products available. The applications. The wide range of applications of factory simulation are production planning and optimization, supply chain management, bottleneck analysis, workforce automation planning, digital twin development. So here, though the process we start initially with respect to production planning, but at the end, the final thing is going to be development of a digital twin for an entire factory. May not be for an entire factory, at least as a preamble case, as a pilot case, we should have for a single machinery setup. Advantages. Of course, a factory simulation is quite versatile. It's a powerful tool, but we need to quantify the advantages. So in this regard, basically it reduces the cost and the waste, improves efficiency and productivity, helps in decision making and risk assessment, and finally, it supports lean manufacturing and Industry 4.0. And today, the term Industry 4.0 is gradually camouflaging itself to Industry 5.0 because of human interactions. Now, though we have got several advantages, several benefits out of this, but still there are certain challenges are there. Thanks to the development, because these challenges are the opportunities for us to grow a little bit in the future. Complexity in model development. As such, we can't develop. Still, there are some complexities are there, but it's going to be an evergreen challenge and interesting facts are there to overcome this particular aspects. Then we need to have accurate data. We can't compromise with respect to data availability. So therefore, we need to have accurate data. Then computational power requirements. Yes, the power requirements are going to be high. Why? Because today energy efficiency is need of that. So we need to have a thorough knowledge, thorough understanding, and adequate knowledge is necessary with respect to the computations, especially with power requirements. Then integration with the real world systems. So the end product, though we start with some sort of initial design activity, but the final output is solely is going to over around a digital twin technology. So therefore, how do we interact, how do we communicate the data, connect and communicate the data is going to be the interesting challenge. So thank you all. So hope you might have had a good preamble with respect to factor simulation. In the future lectures where we'll get introduced to the software, the ways, the means, how to work, we'll kickstart with the thing. So happy learning. Thank you all.